Hey folks, welcome to my channel number 10. So there we have the problem on our screen. Find the derivative of the following. Square root of x square plus y square equals tan inverse of y by x, right? So we have an implicit function here for y, and it's okay to represent our final answer in terms of y and x, right? So this particular problem, I'm going to do it by the method of substitution, where again, by making an appropriate substitution, we are able to reduce this entire expression, what we have on our screen, to a much simpler expression, right? So, what is that substitution that will help me simplify this particular expression is what we'll have to arrive at, right? So, I'm going to write my LHS. I'm going to tweak it a little bit so that it'll help you understand why we are making a particular substitution in this particular problem. So my LHS is nothing but root of x square plus y square, right? Now what I'm going to do, I'm going to divide by x and multiply it by x, right? So my expression does not change. Now I'm going to take my x inside the square root, right? I'm referring to the x in the denominator. And when I take it inside the square root, what do I get? And then my x, because I'm taking it inside the square root, I get an x square, right? Because my x is nothing but square root of x square, right? I write x as it is. I open my square root and I can write this expression as x square plus y square divided by x square, right? So x square plus y square divided by x square, right? Which can further be written as x times square root of, again, I have a 1 plus y by x the whole square. So therefore, square root of x square plus y square is nothing but x times square root of 1 plus y by x the whole square. Right? Now I'm going to use this expression to solve the rest of my problem. So I have this equals tan inverse of y by x, right? Now I'm going to do a substitution that will help me eliminate my y by x, right? And what is that substitution? The best possible substitution would be y by x equals tan theta, right? Y by x equals tan of theta, okay? And then which means my y equals x times tan theta, right? And when I put back y by x in terms of theta, you will understand why am I actually making this substitution, right? So I retain my x as it is. And when I do a square root of 1 plus y by x the whole square, what do I get? My y by x is tan theta, right? So I get 1 plus tan square theta, right? So what I've actually done is I've eliminated my y and I have an expression in terms of x and theta, right? And then I have on my RHS, I have a tan inverse of tan theta. And what is that equal to? My tan inverse of tan theta is but n theta, right? So by making this substitution, y by x equal to tan theta, you now have x times square root of 1 plus tan square theta, which is my LHS, let me highlight it in yellow, equals theta, right? So I go to the next line and I'm going to make one more simplification which looks possible from the expression I have on the left. What is my secant square theta minus tan square theta? I have this identity secant square theta minus tan square theta equals 1. which means my 1 plus tan square theta is nothing but secant square theta, right? So therefore, I have a square root of secant square theta. That's nothing but x times secant theta. So I have x times secant theta equals theta, right? So this is what I have. So I'm going to differentiate this on either side, right? Let's move to the next line and you will understand why am I doing this, right? X times secant theta equals theta means to find dy by dx, right? I have my substitution here y equals x times tan theta, right? So let's highlight it in green. And with this, I apply my product rule to arrive at dy by dx, right? And what is my dy by dx? I have my first function x as it is. My tan theta becomes a secant square theta. But remember, folks, we are differentiating this with respect to uh, x. So I still need to differentiate the inner theta with respect to x, right? So let's do d theta by dx. So all that we are doing is differentiate tan theta with respect to the inner theta and then differentiate theta with respect to x, right? So I have x times secant square theta d theta by dx and then plus I retain the theta function, which means my tan theta remains as it is now. And then I differentiate x with respect to x, which is nothing but 1, right? So my dy by dx is nothing but x times secant square theta d theta by dx plus tan theta, right? And I'm going to highlight that in green as well. Now, we know what is our theta, right? And we know what is our dy by dx in terms of theta and d theta by dx. So all that we got to figure out is what is my d theta by dx, right? So let's go to this expression, which I will highlight in yellow. X theta, x times secant theta equals theta, right? And let me apply the product rule here. When I apply the product rule, I get x times my secant theta d by dx of secant theta is nothing but secant theta tan theta, right? So I have a d theta by dx because I'm differentiating with respect to x. And then I go to the second part of the product rule where I differentiate my first function with respect to x, which is nothing but dx by dx, which is 1. And then I retain the secant theta as it is. I have a 1 into secant theta, which is a secant theta, equals theta. When I differentiate it with respect to x, I get a d theta by dx, right? So this is what we have, right? So I know that with a little bit of rearrangement, I can figure out what is my d theta by dx. So let's go to the next line and write down what is our d theta by dx, right? So all I'm doing is a bit of rearrangement out here, folks. So my x secant theta minus 1, right, becomes equal to minus of secant theta. So this is what we have. And I know that from this particular expression, I can arrive at my d theta by dx, right? Just take a glance to see if everything is okay. Yes, right? So I go to the next step. I write what is my d theta by dx, right? So my d theta by dx, when I represent it in the x by y format, I get minus times secant theta divided by x times secant theta tan theta minus 1, right? Or let's write it like this. I remove this negative sign and then I write this as 1 minus x times secant theta tan theta, right? So it doesn't change our expression. So that's all we have with respect to d theta by dx. And let me highlight this in yellow, right? So we have our d theta by dx, which is equal to secant theta divided by 1 minus x times secant theta tan theta, right? Now I go up. You remember the green expression which we highlighted. I'm going to pull it out and write it again before we make the appropriate substitutions, right? I go to the next line. I have my dy by dx equals x times secant square theta divided by 1 minus x times secant theta tan theta, right? So how do we write this? I just replace my d theta by dx with what we have in the yellow expression, right? So this is what I have as my answer, but my answer is in terms of theta, right? So I need to put it back in terms of y and x, right? So that is what we're going to do in the subsequent steps. So I take a glance to see everything is okay. Now we have this entire expression. We have a secant theta, we have a tan theta, we have an x, right? So I know that I don't have to disturb the x for now, but I know that I should not have my final answer in terms of theta. I need to put it back in the form of, y and x, right? And what is the substitution that we originally made? The substitution that we originally made is tan theta equals y by x, right? So what is my secant square theta? My dy by dx equals x times secant square theta minus tan square theta equals 1, right? So I can write this as 1 plus tan square theta into secant theta is nothing but square root of 1, I'm sorry, 1 plus tan square theta, right? And then I do a whole divided by, I have 1 minus x times secant theta tan theta, right? So I retain the tan theta, but then I express my secant theta like what we did in the numerator as square root of 1 plus tan square theta dot tan theta is nothing but I retain it as tan theta for now. This is what I have as the first part, and my second part I still keep it as tan theta itself, right? So I don't have to disturb it. Now I know what is that substitution I will have to make to put back my answer in the form of y and x, right? So let's go to the next line. I'm going to try and simplify this expression further because I believe that this can be simplified before I make the substitution tan theta equals y by x, right? And what do? I write it like this. I do a simple cross multiplication. I go to the next step and I rewrite this, and I believe that will help me do a little bit of simplification. And let's see what is that simplification we can do, right? And when I expand the first expression, right, I get x times square root of tan square theta, which I write it as it is, right? And then I get a plus of x times tan square theta dot square root of 1 plus tan square theta, which I write it as it is. And then I move to the next part of the numerator. I have a tan theta, which I write it as it is. And then I have x times minus of x times tan square theta into square root of 1 plus tan square theta, right? So I know that this is a pretty long expression, right? So this is what we have, and I retain the denominator as it is for now, right? I know that I have an opportunity to cancel out which are the ones. Let me take out my drop in. I can cancel out this term with this term, right? Which is nothing but x times tan square theta square root of 1 plus tan square theta, right? And then I'm left with dy by dx equals, and I have to express it in the x by y format. I have x times root of 1 plus tan square theta plus tan theta divided by 1 minus x times square root of 1 plus tan square theta into tan theta, right? Now I think we have a simpler expression in front of us. I think we are good to make the substitution now. So all that I'm going to do is put back my tan theta. And what is my tan theta? Drawing your attention to the original substitution that we made. Our tan theta was nothing but y by x, right? So I'm going to put back tan theta equals y by x and solve for dy by dx, right? So I have 1 plus tan square theta, which becomes 1 plus y by x the whole square, which is nothing but x square plus y square whole divided by again an x square, right? And then I have a plus of tan theta, which is nothing but my y by x, right? Y by x. And then I go to my denominator, I have a 1 minus x times, again I have a square root of 1 plus tan square. So I copy this expression as it is. Into again I have a tan theta, which means I have a y by x, right? So this is what I have, and I can do a little bit of cancellation, right? So my numerator, this x square, right? I'm just going to highlight it in a different color. I can pull out of the square root and write it as x, right? Which means this x, which I'll again highlighted by yellow, and the x square inside the square root can be cancelled out, right? So what do I get now? I get a square root of x square plus y square, first part of my numerator. And then I have a plus y by x, right? I write it as it is, right? So this is my numerator now. And then I will have to go down to my denominator. I have a 1 minus x times square root of x square plus y square by x square into y by x. Again, an opportunity to cancel out the x here. I'm highlighting it in yellow, folks. I'm canceling out x with the x term of y by x, right? Which means I have 1 minus y times square root of x square plus y square divided by x square, right? So this is what I have. And then I'm going to move to the next line. I'm just going to copy this expression as it is, right? Let me highlight it in green. And when I move to the next line and do the cross multiplication, what do I get? Again, I get an expression of the term x by y format, but this time I will have x times square root of x square plus y square plus my y, right? And then I have my x in the bottom times 1 minus y by x. And I hope you folks are able to get what I'm doing. I'm moving out the x square inside the square root and I'm writing it like this. Right? So this is what I get, right? And again, I have a scope to cancel out the x. I don't think I can do anything further with my numerator. So I copy it as it is. In my denominator, I have an opportunity to write it like this, right? X minus y times square root of x square plus y square. And remember, folks, I still have my x in the denominator. So I have, this is what I have, right? So now I can cancel out the x, right? I'm just going to highlight it in yellow for your reference. This x with this x, right? And therefore, I have my final answer. So this is what I have, right? I don't think we have an opportunity to further simplify. So let me highlight it in pink. And there we have our final dy by dx, right? Just going to highlight the entire thing in pink. That's the color we've been using to highlight our final answer. So there we have dy by dx, drawing your attention to the pink expression on the right of the screen. X times square root of x square plus y divided by x minus y times square root of x square plus y square, right? So again, a good problem for us to understand, how we make trigonometric substitutions in implicit functions and solve problems, right? I hope you found this video useful. Please do subscribe to my channel and support. Thank you.